Hello, it's your math teacher. I thought since there was some confusion about exponential functions, I'd make a short video. So here's y equals e to the x. And if we did do logarithmic differentiation, we'd get ln of y equals ln of e to the x, which equals x ln of e, courtesy of Tim Newton, which just equals x. So differentiating both sides, you get 1 over y times y prime equals 1, or y prime equals y. But from originally, y equals e to the x, y prime equals e to the x. So I do the same thing here with y equals 2 to the x, and I'll end up with dy dx equals 2 to the x ln of 2. And in general, for any constant a, y equals a to the x. Taking logs of both sides, I'll have ln of y equals x ln of a. Differentiating both sides, 1 over y times y prime equals ln of a, so that dy dx equals a to the x ln of a. So you should have that and not have to derive that for anything that looks like y equals 2 to the x, y equals 100 to the x, etc. So then I also made this little chart. Since the derivative of 2 to the x is 2 to the x times ln of 2, that's approximately 2 to the x times 0.693. When I move to 3 to the x, the derivative is 3 to the x times ln of 3, it's now 3 to the x times 1.0986. So there's some number, e, and that's why it's magic, between 2 and 3, but closer to 3, such that ln of e equals 1. So, moving on. What you should know automatically is if you have, something like y equals 75 to the x, the derivative is 75 to the x ln of 75, etc. Now, let's bring in the chain rule. I have y equals 5 to the x squared. No problem. Dy dx equals 5 to the x squared times ln of 5 times 2x. Don't forget the chain rule. Y equals 3 to the root x. Dy dx equals 3 to the root x times ln of 3 times 1 over 2 root x. An ugly one. Y equals 3 to the e to the x squared. You got that? Dy dx equals 3 to the e to the x squared times ln of 3 times e to the x squared times 2x. And lastly, uglier. Y equals 2 raised to the e to the sine of x squared. We're just going to be doing the chain rule a few times. Dy dx equals 2 to the e to the sine x squared times ln of 2 times e to the sine x squared times cosine of x squared times 2x. What a mouthful. So, I think this is where the confusion, and I maybe made a wrong statement. When you must use logarithmic differentiation is when you have something like this, y equals x to the sine x. I don't have a constant raised to x. So here I do ln of y equals ln of x to the sine x, which equals sine x times ln of x. And now I differentiate implicitly. 1 over y times y prime equals sine x times 1 over x plus ln of x times cosine x. So finally, y prime would be equal to y, which is x sine x, times sine x over x plus ln cosine x. I hope I haven't put you to sleep. Have a great weekend and see you on Monday.